Hi, this is Pierre Sabak, and today I'm going to be interviewing Dr. Manjir Samanta-Laughton. We're going to be discussing two books, Punk Science and The Genius Groove. I'm really interested in these two books because they present an interesting deconstruction of science. By that, what I mean is that in some respects, they're fairly conventional, but in other respects, they're actually paradigm changing in terms of that what you attempt to do in terms of science is actually inject the missing component, and that missing component is consciousness. So, consciousness is the foundation to everything in terms of the universe and in terms of this matrix. And so, today I really wanted to start with the conversation of consciousness and how you see consciousness is relevant in terms of the scientific paradigm and in terms of building new constructions which are relevant for in terms of scientific study. So thank you for being here as well. Thank you.
Thank you for having me on the show, Pierre. It's lovely to see you again.
Yeah.
Yeah, that's a really, really good question to start with because I think when I started talking and looking into consciousness in science, which was, gosh, about 30 years ago now, it was very much a taboo subject. And science as a whole, the orthodox scientific paradigm has done a lot to try and get out this thing called consciousness out of the system. It's changing now, actually. People have got to a point where they're going, well, maybe we should have a look at this thing. But at the time, it was very much pushed out, and it has been for, a number of 100 years, when science and religion sort of split, and we went into the sort of Newtonian reductionist paradigm, it's often called. And it's science has been going that way ever since until very, very recently. So, what the interesting thing that happened that started to change that from a physics perspective is that around the 1960s, some quantum physicists started to look at really what it meant in quantum physics, what the results of the experiment actually meant. Because I don't know if you've heard of something called the double slit experiment.
Yes, that's in terms of the particle as being represented as a particle or a waveform. And so intrinsic to the nature of the universe is the observer. And this game would link into relativity as well in terms of that everything is relative to the observer. So yeah, we have this split. And you mentioned this split also in terms of is it the electron and the proton or matter and antimatter in terms of that there's a split? Is that somehow related to wave particle duality? And I'm sorry if I sound very ignorant about this because some of the concepts which you were explaining in your book were very new to me and I found them very fascinating. So, if you could explain that kind of, shall we say, that relationship between wave particle duality, which seems to be somehow related to relativity, and yet at another level also seems to be related to matter and antimatter. So, I'm saying to you, is there this relationship between all of these different strands of science? Can we pull them together in some way?
Well, absolutely. I think we can, and that's really what physicists have been looking at. I'm not a physicist, by the way. I'm a medical doctor by training. So, when it comes to the physics, I've had to learn not physics itself, but the bottom line of physics. So I'm not trained in all the equations and everything like that. But yeah, I think we can. And physicists have been looking for the theory of everything that's trying to bring the science of the very large, like the cosmology and sort of stars and things like that, with the science of the very small, the subatomic behavior, and bring that into a unified theory. At the moment, what we've got in mainstream science is quite inelegant, and they're trying to bring something together into an elegant whole. But with regards to the first thing that we were talking about, when it comes to these famous, we're coming up to 100 years now of the sort of double slit experiments and the findings of quantum physics. that was really the big revolution, because for the first time, as you said, Pierre, we put the observer back into science. And before, it was like we did experiments, we observed them, and we were not interacting with them. But this, for the first time, showed that a particle behaves like a wave or a point particle, depending on whether or not we are observing it, and the behavior is different. And I don't go too much into the double slit experiment. You can look that up online. There's so many explanations out there, because it's getting into technicalities. But the bottom line is, it brought back that the behavior of reality depends on whether we're observing it or not. And that was the big revolution. And then that got to the 1960s, where a group of physicists like Elizabeth Rauscher and Fred Alan Wolf and Amit Goswami started to look at this sort of, this paradox, this quantum physics paradox. Like, how is it that the observer effect is present? And aren't we sort of separate from the universe? And they started to realize that it makes a lot more sense if consciousness is actually fundamental to the universe. And so it's not that consciousness arises out of matter, which is the biologist perspective, that consciousness somehow emerges from our neurons. It's that matter arises out of a fundamental consciousness itself. And then our brains become like an antenna for consciousness. So, well, not just our brains, but really all of us. And we, as biological beings, are kind of designed to bring through consciousness and articulate it. So it's much like, as Gary Schwartz says about the mobile phone analogy. Just because your mobile phone gets broken, you don't start thinking that your friend has disappeared. You know that your friend's voice has been coming through the frequencies and your phone just is picking up those frequencies, and you're able to hear your friend's voice. But that's how we've been seeing consciousness in the brain. We've been seeing that consciousness is produced by the brain. And having done a neurology, like I used to work on a neurology ward, and I used to look after patients with Parkinson's and strokes and things. So when people have a stroke, sometimes they lose some of their faculties in terms of the ability to speak or recognize even their own relatives. So we think, oh, okay, the brain must be responsible for consciousness. But when you go through this physics perspective, it's no, the consciousness is fundamental and matter arises from it. And basically, the brain is sort of bringing that through. So if there is some brain damage, there will be some change in faculties, but it's not the originator of consciousness. And that was the big step forward.
And I think that in terms of, I think his name's Professor Karl Pribram, he talked about the nature of the holographic brain. And I think that that's interesting because, as what you were talking about in terms of the micro and the macro level, so in this respect, we've got the micro level, which is the neuron. We see that the neuron, in terms of how it stores information, is holographic. And I think that there is this relationship also at a macro level as well. And I think that this is also found in your research in terms of that space is holographic and somehow it's able to imprint information in a way which is still not really fully understood, but is certainly implied at the quantum level. So, what are your feelings about the fractal nature of reality? Do you have any opinions on this?
Yeah, I totally agree. I think that so in terms of the holographic nature, if I just maybe explain to people what that means in case so if you were to look at like your credit card or something, it usually has like a holographic sort of image on. And the way that those images are created are through lasers, and where the lasers can be bounced off an object, and where they interact, those lasers that have been bounced off an object, and then you can put that those lasers through a sort of photographic film. And if you then shine another laser through that film, what you'll see is like a holographic image of that object. So what's happened is the information about that object has been stored in that film. And what you'll see on the film is just kind of like a swirly image. But the interesting thing is, if you cut out a bit of that film and then put a laser through that small part, you don't just get a tiny bit of that object, you get the whole object. Say it was an apple that you were bouncing the original lasers off, you actually get the whole apple again. So that's kind of seen as a holographic principle. In actual reality, the image isn't as sharp, but we're talking about the principle here that the information of the whole is contained even in the smallest part. And I do believe that that is how the universe works as well. And I have part of the book, Punk Science, is where I first revealed the fullness of something I call the black hole principle, which I think is a fractal pattern. And you alluded to that earlier, talking about the split of the electron and the positron. But we'll sort of maybe come to that later. But that is really a theory of the universe, where the universe works in the same way at every single level. It's just at different scales. So absolutely, I think that this is like a holographic universe, a fractal universe, you might call, with the same pattern expressing at different levels. And I've spent the last 20 years now finding astrophysics evidence for the black hole principle. And so far, everything has absolutely lined up. And because once you know the simple pattern behind the universe, you're able to make predictions. So that's how I've been able to predict that there's water on Mars, for example, or a number of different predictions that I've made over the years. But yeah, we can talk about that.
Yeah.
So
I've kind of studied what you're talking about, but from perhaps a little bit of a different perspective. So I've looked at the universe in terms of a language, and I kind of describe it as a grammatrix. And again, this links into, I think, what you was talking about in terms of mirror universes. Now, I use the term the mirrorverse, and this was a term which I kind of, well, I thought that I developed, but apparently quantum physicists have been talking about this for a long, long time. But my understanding of this was based on the Xing Ming, because the Xing Ming talks about consciousness as having this reflective characteristic. And I think that that's quite interesting when you're looking at the parallel nature of consciousness and this interaction between consciousness, the physical construct, and the implicated realm of ideas, which are found perhaps, for example, within Platonic thinking, this idea that we have universal forms, which is this implicit realm of ideas, which we can also define as the spiritual realm. And this spiritual realm is particularized, so it's particularized as a particular form. And so when I look at wave particle duality, there's certainly a part of me which is thinking that the waveform is the spirit, which is this information pattern, but then it becomes particularized as the particle. And so, in some respects, Plato's ideas about waveform duality or about the universal forms and particular forms is very prescient in terms of it's very advanced. And when we look at the idea that the universe is, shall we say, this grammatical system, which is this linguistic pattern, which the ancients talked about, the logos, which really is another word for the information field, then the other way of breaking down the universe is not only in terms of a grammatical system, but also as a mathematical system. And this is something that Pythagoras talked about, the mathematics of the universe. And I'm kind of intrigued because obviously this links into fractals and into the representation of the microcosm and the macrocosm. But I'm very intrigued in terms of, shall we say, your perspective on the mathematical universe. Do you have any ideas on this? And I know that you said you wasn't a physicist, and so this is probably quite a tricky question, but yeah, I'd be very interested to know.
yeah, I mean, the ancients, like you're saying, philosophers over the years, they've hit on this on similar ideas for a reason, because the universe is basically geometric, it's mathematical, and the laws that I think when I don't know if you've studied mathematics at all, but I was pretty hopeless, but I got to A level, and I started to break through to a new level of understanding, because I was doing an equation one way and then I would do it another way and hit on the same answer. And suddenly you start to realize that maths is kind of describing a truth about the universe. And I didn't study it for long enough to really get there, but I think it's that truth. And I think that's why mathematicians really go down that route, because you feel that sense of truth. And so I absolutely agree with that. I think the universe can be described by mathematics and geometry, but it also is mathematics is a human language in a way to describe it. Because there's when I got the vision through of the black hole principle, I realized that there's everything is geometry, everything is mathematics, but there's so much more that the human mind can't even fathom, that we're never going to fathom, because it's just so infinite. And every single theory of everything that we get through, even the black hole principle, which is probably the next part of the next big step, let's say, is not going to describe the entire universe. So although mathematics can give us so much in truth, it's not going to be the entire description. So, it does tell us an awful lot, though, of these truths. And yeah, absolutely, there's like a mirror universe that's described in things like loop quantum gravity as well. These ideas are now starting to get more and more fashionable in physics. So they've gone from sort of fringe ideas, and even the idea that we said about earlier, that consciousness is fundamental. So that those things are sort of coming in more into the forefront as well. There's nothing in physics that precludes the concept that you have a mirror universe with negative time. It comes into the equations, it's there, it drops out of the actual mathematics. So yes, that sort of mirror universe you're talking about, yeah.
Yeah, when I read your theories about the black hole principle, in my mind, I just kept reading it as the black hole paradox, and that's just the way that I was kind of interpreting this. And I think it's fascinating because, and I'll be honest with you, I'm only still processing what you was writing about, and it's a little bit like relativity. When I first learnt relativity, I just didn't understand it straight away. It took time in terms of, it's almost like an osmosis. And I think in terms of what you was writing about as well, there's this osmosis where it's just gradually beginning to sink in. But basically, behind what you're talking about, the black hole principle, is this paradox where it's almost, and correct me if I'm wrong, because I could be quite easily wrong, but we have almost two different timelines which are running simultaneously, and they're running, one's going backwards and one's going forwards. And when they meet in the middle, which I presume is this reality, they cancel each other out. And so this is our perception of time. But really, and I thought that this was a really, certainly from a philosophical perspective, a really incredible and quite a groundbreaking idea that two timelines are able to cancel one another out and meet in the middle of what we term as this physical reality, which is what we said before is intrinsic to the observer. So could you describe your conception of time and how it works, and perhaps describe it a little bit more elegantly?
Thank you. It's probably best that I talk about the black hole principle properly as well. So as I said, I'm not a physicist. So I was training as a doctor, and I became a GP. And throughout my training, I probably spent a bit too much time in the library looking at quantum physics and cosmology and that sort of thing, instead of looking at anatomy. So a long story short, but I found myself in 2003 with suddenly some free time. If you want to know the full story of that, with the Genius Group. And it was when I was walking in the woods that I suddenly had an experience. I call it a vision, but it wasn't really a vision because I was sort of thrown into it. And I saw how black holes are actually not the destructive monsters that we think they are, but they are the creative centers of the universe. And what I saw made sense of some of the data that had been coming out of black holes. Bear in mind, this is now 2003, and they discovered that from black holes, they were seeing like jets of electrons at almost the speed of light, and also jets of the mirror particle, which are antimatter. So if electrons are matter, then the mirror particle, the antimatter, is are positrons, the mirror image of electrons, and sometimes gamma rays. So the cosmologists and the physicists couldn't figure out what was going on there. But in that moment, I saw what was happening. That you've got a barrier which is, like you said about relativity, that barrier is the speed of light, which we think is the speed limit of the universe, but it's actually the speed limit of matter. So that's what Einstein said, that nothing with mass can go faster than the speed of light. So, but what I saw in my vision is that actually there's a huge amount that's going on beyond the speed of light. And that's a region that we often call dark matter, dark energy. It makes up most of the universe. So 98% of the universe is dark matter and dark energy, stuff that we can't see in directly at all, but we know it's there because of its effects. So basically, what I saw is that there's infinity at the center of a black hole, and basically light is spirals around. So that's the geometry that you're talking about, the mathematical rules, spirals around in the form of, Fibonacci sort of series, and it comes to the edge of our reality. So the light is in form of a photon, and then it's at the edge of our reality, it splits, and it splits into the matter, which, for example, the electron, which then comes out of the black hole at almost the speed of light because it's just slowed down to our reality, and also splits into the positron, the antimatter. And so that's why we see positron and electron spirals coming out of galaxies and things like that, because we also discovered that there's a black hole at the center of every single galaxy. They're not unusual. So there's actually a one-to-one ratio between the size of the black hole at the center of the galaxy and the galaxy itself. So the signs are there going, black holes are created, but the cosmologists have a bit of a blind spot and don't seem to take that on board. So basically, that is the black hole principle in a nutshell. What happens then is there's a breathing process. So it doesn't just create, it also creates a gamma ray burst. So the matter and the antimatter come together again to form light. And that's that annihilation process that you were talking about. So when they come together, because they're mirror images, electrons had negative charge, positrons had positive charge. Doesn't mean the electrons are in any way negative or, sad or anything. They're just like, that's just an assignment. And so they come together. When they come together, they form light, and that comes out as a gamma ray burst. So all across the universe, scientists are seeing these gamma ray bursts that are really powerful and going, what the heck's going on? Why are all these electron jets coming out? Da 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 da. So that breathing process is happening. And the other thing that I realize is this is going on at every single level of the universe. So we see these matter and antimatter jets coming out of stars. We see them coming out of planets. We even see them at the atomic level. If you look again at the way that we look at the atom and the jumps of the electrons, and we say that it leaves an antimatter positron hole. That was Paul Dirac's work. Then you can see that the same sort of thing is happening. The jump of the electron and positron, it forms light. Our neon lights and things like that work like that. As the electrons jump up and down the energy shells, as they jump down, they release light, and that's why we have neon lights. So we're using these principles, but the same pattern goes all the way down. And one of the most stark examples of a black hole at the level of our reality that we see every day is a thunderstorm. So in the late 90s, we started to see that thunderstorms actually had gamma rays coming out of them. Big surprise, they weren't expecting that. So from what I've just said, that black holes, if they're going all the way down, we'd expect that the thunderstorm would also have matter in the form of fast-moving electrons and antimatter coming out of them. Well, the matter in terms of fast-moving electrons are what we call lightning. So fast-moving electrons are lightning. And you might be sitting here going, but Manjir, I thought lightning was caused by static electricity and friction in the clouds. There's not nearly enough power to power something like a lightning bolt. Experiments have been done. People have actually lost their lives putting weather kites into clouds in a storm. Can you imagine putting it's a dangerous thing to do, to actually measure. There's not nearly enough charge built up. So it's a really good case of science actually disproving something. But because they've not got anything better to explain something so everyday and mundane as a lightning storm, they just carry on. And so basically this is going at every single level. And if you're listening to this, you're probably thinking, well, what about the rain that accompanies thunderstorms? Well, that's what I realized too, that means that black holes produce water. Absolutely shocking though it may be. And what are we finding? Water all over space, the biggest pool of water ever found. Go Google it if you, or ask ChatGPT nowadays for this information. And I was able to predict that antimatter would be found coming out of thunderstorms, which NASA found in 2011. I was able to predict water on Mars because Mars is producing its own water within its interior, just like the Earth does. They're all black hole dynamos, basically, that are producing bipolar jets that we normally call aurora, and they're producing water, which we call the oceans. And on Mars, they're renewing. On Pluto, they are seen as icy volcanoes because Pluto's so cold. So the it's firing off the volcanoes, but the water that's coming out of the volcanoes, it's actually freezing straight away. So that's what we call cryovolcanism. So if you look at all the way through the universe, you'll be able to see the same pattern. Now, what you were saying about the matter and antimatter and the timeline, electrons have got positive time. And so we see from the point of view of an electron, time's moving forward. The child grows up to an adult, but it also, at the edge of a black hole, splits into that antimatter as well. So with antimatter, time goes backwards. And this isn't just something that is coming out of my mind. This is in the physics, this is in the equations. And so positrons have negative time. Now together they cancel out and they form light. So you could say in a way that all of our reality is kind of frozen light. So we have experienced growing up from a baby. We've experienced a positive timeline. So you could say that we're seeing reality from the prism of the electron, from the matter perspective, and we're seeing time moving forward and the baby growing into the adult. But there is the other flip mirror of the universe where it's actually going backwards. And then there's the higher perspective, which actually is present there all along. And that's the light that always was whole without any charge. And so if you see from the light perspective, there's no split at all. So it's this incredible thing where we're both split and we're not split at the same time, but we're seeing things from the perspective of the forward timeline. So it's a bit hard to get your head around. But this is how we reconcile the ancient mystics as well, who said time does not exist, or Eckhart Tolle and people like that. And it's like, how can you say time doesn't exist? I mean, Eckhart Tolle himself is dyeing his hair and wearing wigs, because of the passage of time. So he may be saying there is the eternal now, and that's true, but there's also a positive timeline and a negative timeline. And in the big picture, beyond the speed of light, all of that cancels out and everything is happening simultaneously. But below the speed of light, we've got our timeline, and we see Eckhart Tolle going from a child to a man wearing wigs or whatever he's doing to his hair to because of the passage of time. So even the person who's going on about the power of now also is experiencing time. So that's when you look at what the black hole principle is saying about reality and time, that's one of the ways that you can look at it. So I hope that that sort of makes sense to you.
Yeah, it does. It's a really detailed explanation. Thank you for that. And I think if my understanding is correct, and this is what you were saying in the book, you mentioned that black holes weren't really black holes, but they're immense. They're giving out immense amounts of light. But the thing is that we can't see it because the light is traveling so fast. And I thought that this was an immensely intriguing idea and a completely paradigm changing way of looking at a black hole. And in a sense, it made a lot of sense because these black holes are kind of like, well, at the macro level, they're enormous and they must be generating large amounts of energy, or they seem to have a lot of energy. And so that would actually intuitively make sense that they are giving off a lot of energy. And a lot of this energy must be photons. And if we can't see the photons, then one of the explanations might be that it's because that the light is traveling faster than what we can see. And again, that would then obviously, and you're saying that this is possible because, in terms of Einstein and his theory of relativity, what he was basically saying was mass cannot travel faster than the speed of light. But because a photon has no mass, then obviously photons are able to travel faster than the speed of light. I've come across this idea also that magnetism is able to travel faster than the speed of light. But this was also kind of disregarded by the early scientists because they couldn't really explain it. It didn't kind of fit in with the theories of relativity, so they just kind of left it. But if what you are saying about photons and in terms of that they don't have mass and therefore they can traverse or go beyond the speed of light, then that would make sense for other types of forces as well. And I kind of liked how you explained that in a sense that the black hole is like a fractal because obviously you've got these huge black holes at the center of galaxies, but then they translate a smaller resolution into, let's say, the sort of the ecological systems of a planet in terms of the electromagnetism and in terms of the meteorological phenomena, but also in terms of, you also mentioned black holes being the size of atoms. And I kind of thought, wow, that's another really, really interesting idea. And I've never heard that before, but that would make sense as well. Do you want to just elaborate on that?
Yeah, I mean, it's at different scales, that sort of behavior, and you're right about that a lot of the black hole we're not seeing because it's beyond the speed of light, which means it's beyond our normal 3D consciousness. And people who are mystics are the ones that can see, we call it beyond the veil, don't we? So it is possible to perceive but not measure because all our measurement instruments are below the speed of light made of matter. But we can actually see some of the emissions from black holes that they slow down to our reality. So that's how we're able to measure the jets of electrons and positrons. And also, I think it's at the edge of that reality as they combine again and they produce gamma ray bursts, which is the fastest sort of wavelength of the shortest wavelength of light that we can see in the electromagnetic spectrum. So and there's lots of other things that come from black holes as well. So fast radio bursts, which are basically putting out the whole energy of, like a whole galaxy worth of energy, in about a second. And it's really puzzling scientists. Like you've probably heard of, I think, the wow signal and things like that. And not only is it powerful, it's also extremely fast. Now, the only explanation mainstream scientists tend to have is of their explosions, but if you think that the black holes are being powered by infinity, it's really, really beyond our capabilities of truly understanding how vast this universe is. So it's basically we can measure some of it. We can measure the end result. So you've got the supermassive black holes and the emissions that some of it we can measure, some of it we can't. You've got things like planets, moons, all these craters on even on our moon. Many people have gaze at the moon and they see lights coming out of the craters. There's ice coming out of the center of these craters. These craters are not impact craters, they're upwelling craters. And so hence you get ice in the middle because it's actually water's being produced by the middle of our moon. And you know it's actually coming up. You get that on moons like Enceladus, Saturn's moon Enceladus. There's just basically, like you said at the beginning, different geometries of um of of different bodies, both in planets and also way down to the atomic level, like we were talking about. So there's lots of evidence on our planet as well. So going from the planetary level to the within the planet level, the oceans, volcanoes, earthquakes, volcanic lightning. Have you heard of volcanic lightning? So volcanoes produce lightning, they produce water. We'll come on to this maybe in the second half, maybe, but also producing organics. You know, so down to the earth level, also, like you're saying, down to the atomic level as well. So if you look at the atom again, you know, you can actually even down to the quark level, you know, decades ago, scientists found that quarks actually give off bipolar jets. So one of the signatures of the black hole principle is the bipolar jet. So that is when you have like a galaxy that is giving off two jets at 180 degrees to each other. Now, when it comes to the conventional picture of black holes, people think that there's like a plug hole and things are going down the plug hole. Now, if that was the case, then and people saying, well, things get heated up, and as things get heated up, these jets are produced. Well, it doesn't make any sense. Why would they be at 180? And I'm not just saying this. I've actually been at physics conferences where, you know, somebody's trying to sort out the mathematics and the angular momentum of all of this and can't really, you know, make it happen. Oh, the magnetism as well as part of this, like you were saying. So can't really make that happen, that the 180 is down to going down the plug hole. I think it's to do with the beyond speed of light geometry, you know, the point that you made at the beginning that the whole universe is geometry and mathematics. And that's why it's the end result of that geometry beyond the speed of light that is bringing out the jets at two poles. And that also happens at the quark level. So at the subatomic level, it's happening within the atom as well, where you're getting, if you revisit radioactivity, what have you got? You've got you know, the gamma ray radiation, you've got beta radiation. It's an electron, you know, and alpha radiation is like a helium atom. And so you've got all of that sort of happening within the atom itself. You know, so you've got the same sort of pattern going on. And what do we see in the sun? We see helium. You know, so it's the same pattern. If you start to know what to look for, a lot more work has to be done on this. I'm not saying it's complete. I'm finding new things all the time. But so far, when when you start to understand the simple pattern, you can start to see this going all the way down. It can help us to understand the sort maybe some of the vortices on this planet. You know, perhaps something like the Bermuda Triangle, if one believes that that is, there's all sorts of controversies about whether that is so-called real or not. But there's areas of this planet of high volcanic activity that are nowhere near the kind of zones of tectonic plates and things like that. They're nowhere near those danger zones. They're inland, you know, so it doesn't fit the kind of, you know, paradigm, the conventional paradigm. So why is it that we have volcanic activity or earthquakes that go at the same time across the planet? Are these the bipolar jets that go from the center of the Earth? Is that why we get one earthquake and then the other, and in almost the same time at two aspects of the Earth. So when you look at the way that when you've got that basic pattern, that's when you can start to make these predictions. And one of the predictions I've made about the Earth, for example, is that you should be able to, well, you can probably know as well, when you've got the black hole principle, you've got the gamma ray burst, you've got the fast moving electrons, and you've got antimatter. Different level, different forms according to different levels. On the stars, it's slightly different particles, neutrinos, antineutrinos, but you've got those different levels. The principle is the same. You've probably got the production of water. So where do we see this? We see this in hurricanes, and people trained a gamma ray telescope onto the Earth in 2018 and indeed found gamma ray bursts in hurricanes, gamma ray bursts, antimatter in hurricanes. So once you know the basic principle, which is quite simple really, you can start to make these predictions. And when you have a situation such as hurricanes, which cause quite a lot of devastation, people are desperate to understand how they work, how they accelerate. Well, as far as I know, I'm the only person who predicted that gamma ray bursts would be found in hurricanes, that antimatter positrons would be found in hurricanes. We knew that there was lightning there. So that's just another sort of micro of the micro and this fractal pattern that you've been referring to.
I've got one last question before we wrap up this first half. And I guess it's our conventional understanding of a black hole is that it's a collapsed star. But obviously, what you are saying, we could perhaps look for other types of interpretations. And so, is it more to do with the quality of space, or is it to do, for example, with the electrons? I mean, or is it just a collapsed star? What's your understanding, particularly of these large black holes, which have been conventionally described as collapsed stars? Do you subscribe to that theory? It is only a theory, but it's obviously taught in such a way as that now it's like fundamentally accepted. What's your position on this? Because obviously, what you're offering the audience is a very complex and a very sophisticated argument about the black hole, and in terms of how the black hole can be understood to be found throughout pretty much all of the mechanisms which are the electromagnetism and the mechanism that makes up the universe. This is a fundamental property which is behind the creation of the universe and is behind time and is fundamental to our understanding of consciousness. So, put simply, are black holes collapsed stars at the macro level?
Not in that way that's understood by the Orthodox, no.
Right, okay, that doesn't surprise me, and I do think that your explanations of black holes do make sense. And I mean, you know, part of the question is, well, if a star's going to collapse, why would it collapse? Why wouldn't it just fizzle out?
You've got back to the 1950s, we saw what we thought were supernovas explosions, and the telescopes were trained on an area and saw huge amounts of gamma rays. Now, in the Orthodox sense, they just think collapse or explosion. Those are the kind of mentality they've got because they're not understanding that most of the universe is beyond the speed of light. It's elegant, it's effortless, it's powerful. And, so if you're thinking just in 3D terms, you're thinking explosions and implosions. So when they trained their telescopes on these gamma ray bursts that they saw in the 1950s, they saw supernova, exploded star. Now, that same area has again got gamma rays coming, but the star's supposed to have gone. The reason why is because of this breathing process that sometimes gamma rays are produced and sometimes they're not. You've got this breathing from matter and antimatter to being created to gamma rays, and it's a sort of, it's intermittent. It's not always present. So they're going on the same area and they're finding that there's gamma rays again. So was that an exploding star? No, these are paradigms that we are so entrenched in now that it's going to be very difficult for people like people who are physicists who've learnt this all their lives to stop thinking of black holes in terms of collapsed stars How can there be when they're in the center of every single galaxy and there's a one-to-one ratio between the size of the black hole and the size of the galaxy? That's a creative relationship, obviously. But because they're so far going down that road, they find it difficult to let go of all that.
I do think in terms of the black hole as being a fundamental property of space, kind of does make a little bit more sense than this idea that a star has somehow collapsed on itself, because that leads to all questions which so far they haven't really been answered that well. But I do think that what you're talking about in terms of the way in which the system conditions people, and I mean, it's like the Big Bang is taught as though it's an absolute fact when it's just a theory and it's one of many competing theories. And I'm not saying that it's intelligent or unintelligent, I'm just saying it's one of multiple theories. But to me, and again, this is something that I came across when I was studying occult philosophy, but this idea of the large infinite and the small infinite. And I think that this, in a sense, is kind of interesting, particularly when you start putting the dynamic of time. And so you can have these large expanses of time, which theoretically can go on infinitely, but yet in terms of the spiritual realm of ideas and then the physical realm, you've got the small infinite and the large infinite. And again, these are really intriguing concepts. Your descriptions of the black hole principle have been really enlightening. And I think what I really enjoyed about this conversation and this discussion is that it's really challenging people's paradigms about the black hole. And I do think that this is really, really necessary, because we need a multiplicity of different ideas in terms of science, in terms of trying to really understand what's happening in the universe. And I think what's happening is that we're getting very rigid and very fixated in our ideas. And it's almost like we're sitting on top of our laurels and we're saying, well, look, we've got everything figured out. And yet, a lot of the fundamental presuppositions and the premises which are being laid out are fundamentally wrong, or are problematic, or certainly can be interpreted in a multiplicity of ways. And I think that your research, Punk Science Inside of the Mind of God, is a really good starting place for really beginning to understand a lot about what's happening, but also presenting really invigorating and new theories and new ideas. And this is so much needed, I think, and not only just within science, but in academia in general, because we've got a dearth of information in terms of that. We're lacking so much information, and I often talk about this on my show in terms of that the human race is amnesic, in terms of that we've lost our direction, we've lost our origins, our history, and we're kind of floundering about, and we kind of think ourselves so superior and that we've got so many things figured out. But I think that what your book proves is that we really need to start looking at things freshly, and I think that this is important message which is found in your work. And I think what's so wonderful about, and this is especially about punk science, is that you take very, very complex ideas and you break them down, and you break them down simply. But also what you do very successfully is then you integrate the most important part of this, which is consciousness, which is so important to understanding the universe and understanding matter and understanding the more subtle realm of spirit as well. And all of the philosophical ideas that actually brings out and brings to the table. Because I think, and this is what philosophy does, philosophy asks the difficult and the big questions, and then science tries to answer those questions. And in a sense, that's not a problem. It only becomes a problem when science becomes dogmatic and when
Mm.
science refuses to look at alternative evidence or alternative viewpoints. And this is why I think your book is so enlightening and very enriching. So I just want to thank you again. And if there's anything that you want to add, or if you want to talk about your website or the workshops that you do or the books that you've written, this would be a really good place to do that.
Okay, yeah, just to add to that, James Webb Telescope. Suddenly we had the James Webb Telescope and threw a lot of things up in the air, and I'm hoping that this section has helped people to open the mind. Thank you so much for saying those wonderful things about my work. So yeah, if you go to punkscience.com or paradigmrevolution.com. Punkscience.com is a lot easier to spell. So you'll get to my website, Paradigm Revolution, where you'll find out what I'm up to. can get the Genius Groove and Punk Science both on Amazon. So yeah, and sign up for my email list, because you'll get to hear about the uh, the group that we've got going. We do monthly calls called the Conscious Science Club, and lots of other stuff. So yeah, I would love to connect with people on that, and loads more to come.
Thank you very much. Thank you.
Thank you.